Well, hello from the Scott Learning Center. This is Jay Mahaffey. I'm currently manager of Bayer Scott Learning Center in Scott, Mississippi. We've been having a lot of questions coming in the last few days about soybean planting, soybean skip, soybean replanting, and a lot of the issues that we've tried to address over the last several years here on the Learning Center. I thought I'd take a few minutes today and review some of the data that we've generated over the last few years in regards to that kind of subject. Soybeans are the largest acreage crop we support from the Scott Learning Center. Arkansas, Louisiana, Mississippi, and Tennessee had about 6.5 million acres of beans in 2019 with an average yield of about 49 bushels an acre. The result of having such a large acreage relatively locally is that soybeans are planted a lot of different ways. They're on a lot of different row configurations. They're planted using all kinds of different machinery. They're planted over a very long time. So we get a lot of questions about replanting, skippy stands, and a lot of issues that happen in soybean fields. Over the last few years, we've done our best to simulate some of those difficulties so we can have some data to hopefully help support some of the decisions that have to be made in soybean production. There are a few things about this work you need to realize going into it. Number one, we do our best to simulate those difficulties. However, each field and every case is different. So everyone needs to be evaluated differently. Each field that you have a concern about, somebody that is comfortable with evaluating stands and disease pressures and those kinds of things need to look at each one individually. Our planting and stand studies typically involve simulations of problems. Our plants are rarely diseased in those cases, and the presence of a disease, seedling disease, or a very early season disease in soybeans would have an influence on your decision that you'd make about replanting, so be aware of that. Also, carefully scout each field before you make decisions based on this data or really any other data for that matter. Also, please don't mistake this data as guidance to deliberately plant greatly reduced stands. In the last 10 or 15 years, soybean planted stands have been going down anyway, and I think that's been agronomically a positive, but there is some yield response in soybeans to stand, and the lower and lower we drive this, those stand counts, number one, we have the potential on some level to influence yield, and also you have a great influence on the likelihood of replanting. So this work is really meant to simulate what is possible when bad things happen in the field. It's not really meant to give you some guidance about trying to drive populations to really, really low levels. So what have we done? We've evaluated skippy stands, missing rows, reduced stands, and all sorts of other things. We're going to have a few videos about this over the next few days, I hope. But we also would offer you this. We take most of our subject matter from conversations that we have in meetings and phone calls and people that call. If you have an idea or an issue that you think we could provide some data about, we'd be happy to try to incorporate it into our program, if not this year, as soon as we can. So give us a call if there's something you'd like us to add to this sort of work. So by way of example of a few things that we've done over the years, there are lots of questions that have been asked historically about twin row planters. You know, a lot of those twin row planters don't run well down the top of the bed. We have a hard time keeping them on top of the bed, and we wind up with a few skips through the field. This work actually started as we were evaluating the yield response of soybeans to those skips. So what we did was I actually made a sheet that would allow me to calculate the parameters to put in the planter so that I can then introduce skips of a known size into a known population of soybeans. And we call that a skipulator instead of a calculator, but it's our technique of being able to plant treatments like the ones on the screen here. We'll plant things like 60, 90, 120, 150,000 seed per acre. We'll introduce skips of a known size from 12 to 36 inches long. And the biggest skip that we would typically introduce into a test like this would be about the width of the row spacing. So we're on 38-inch rows. A 36-inch skip is what we put in this test. Then we harvest that with a commercial machine. We're able to then figure out how the soybeans can compensate or not compensate for the skips when they do occur. Y'all have seen these things in the field. As you look down the row, you think that looks like a pretty good stand, and then you look at it from the side and it doesn't look so great. And that's when the question comes up, what should I do with that? Can it compensate? Can I live with it? Should I keep it? Should I replant it? And some of this work was meant to be and generate some material that could help with those decisions. There are other factors to consider, but this is what they really look like in the field. We learned a few things over the years of trying to do this. Number one, our very precise planters that most of the ag world has acquired over the last few years don't like mistakes being intentionally introduced. But we have figured out ways to do it and do it successfully, so we wind up with the test planted. And in the process of doing this, there are always a question that comes up, it seems. What about the difference between single and twin row soybeans? So I included this slide. This happened to be a case where we compared single and twin row across a bunch of different treatments. It's only one variety, but it was still pretty representative of our historical data, so I included it. Typically in our work, the twin row is rarely, if ever, lower yielding than the single. We don't see a huge yield response from it, but it's usually in that neighborhood of 3 or 4 bushels an acre in most of the trials and studies that we do. And I just thought that was a interesting piece of data that a lot of folks are interested in. Now, when you look at the results of this sort of work, these are the yield results that are on the screen now. When you look at the solid planted, the blue bar is a solid, the orange bar is a 12-inch skip, the gray bar is 24-inch skip, and the yellow bar is a 36-inch skip. These are averaged across the populations that we planted in the test, and all that data is available to you. I'm just kind of hitting the high points today. But you see here that even with a 36-inch skip on those single rows, we were able to just practically fully compensate for those skips through the year. So having a few skips scattered through a soybean field, as long as the stand is healthy and not diseased, and reasonably well covers the ground, is not the end of the world. There is a case to be made that we could keep some of those stands. Now, another thing we've done that sort of lines up with this is there's everyone, it seems, around the ag world, us here at the Learning Center included, has a field where water backs up on the end of it. Something bad happens. It just doesn't look quite right. Part of it goes underwater. Some of it gets planted into sand versus clay, or didn't come up well, or whatever. So we went out over the years and took a group, or over this year, and took a group of varieties. We planted them into a system where we had either uniformly thinly planted stands from one end to the other, or we had a similar portion of the field destroyed. And what I mean by that is we planted 160,000 seeds in a check plot. Then we reduced that stand 20, 40, and 60% to plant 128, 96, or 64,000 uniformly from one end to the other. The other distribution was a non-uniform distribution. So what we did to simulate the 128, which was an 80% of the check stand, was went out and destroyed 20% of the plot. Then we did a similar thing to destroy 40% to get 96,000 and 60% to get 64,000. That's on the acre. So what they looked like in the field was like this. Some were uniformly planted from end to end, either at the normal populations or at a thinner population. Then there was a paired plot next door where we went out and knocked out a similar percentage of the land area in the plot. So you had the same population on the acre, or the portion of an acre. It was just one was uniformly distributed, one was in clumps through the field, simulating those washed out ends and bad things that happen in the soybean field. When you look at the data, the yellow bars are actually the uniformly planted stands, and I doubt there's statistical significance among those yields. But you see, even at some of those lower stands, we were still able to make very good yields. So as long as we have healthy plants that cover the field fairly uniformly, there is a case to be made to keep some of these thinner stands. However, the red bars represent the clumpy distributions, and you can see as soon as we started to cut those clumps out of the field, yield started to go down. So if you have one end of a field that's washed out, or one end of a field that does not come up and doesn't cover well, or has disease or whatever, that's the case where you need to go out and do something about that, because that is a yield influence in soybeans. Now we'll have a lot more of this over 2020. Our next video will contain a summary of a bunch of other topics that I want to keep these videos to about 10 minutes. And we've done some work with differential soybean emergence, replanting simulations, planter configuration evaluations to really tie all this together. So we will have a video coming, I hope, maybe once a week or twice a week based on demand. And we take requests for this. We have some material you think you'd like to see or something we could do along this line that would help. We'd be happy to try to address that. Thanks for watching, and please come see us this summer. Stay tuned for more videos from the Scott Learning Center in the near future. If we can help you, feel free to give us a call or send us an email at one of these addresses on the screen. You can also contact your local Bayer representative for more details. We'll all be happy to try to help. And we'll see you this summer.